All right.
All right. And uh, thank you very much for coming to this meetup. Our special guest this evening is Joe Guadagno, is with Quicken Loans and is uh, actually the director of engineering at Quicken Loans, and he's been a longtime .NET developer, is an MVP in .NET for over 10 years. And we'll, all of this information is available on the meetup page. But I'm a, tonight he's going to be talking about application architecture patterns. And I will, at this point, get out of the way and let Joe talk to us. Thank you very much for taking the time, Joe. We appreciate it.
No worries. Let's see if I can share a screen. Let me know when you can see the PowerPoint slide.
You're good. I can see it.
Okay, cool. Thanks for your introduction. Thanks for having me. I wish I can be down there, but the great thing or the positive side I see of us all being remote and virtual is I get to meet a lot more people without having to sit on an airplane as much. Although my frequent flyer miles are just not going up the way they used to uh, last year, but at least it's a lot easier to expand and get good people all over the place. Like Doug, you were mentioning how you spoke at your first international event, which looking at the glass half full, it's a great thing that you got exposed to. Just like I got exposed to being able to speak here in Memphis. So enough about that. So here today we're going to talk about application architecture patterns, and that's three buzzwords all in one. And we'll cover a little bit of what that means in a minute. But a little bit about me. My name's Joe Guadagno. Most people call me Joe G. I am a director of technology at Quicken Loans. I lead 5 different teams in our technology team responsible for parts of our mortgage process. Let's go to next slide. So you can follow me on any one of these social medias. I'm pretty popular or pretty active on Twitter at Jake Guadagno, Facebook josephguadagno.net, LinkedIn Joseph Guadagno, my blog jjg.me/about me, and I also stream 3 times a week at jjg.me/stream. If you're active on most media, you can follow me somewhere at Jake Guadagno. Don't have that yet on YouTube because I don't have enough subscribers. If you like what you see today, like I mentioned, I stream 3 times a week, Monday, Tuesday, and Wednesday at 7:30 Central Time, if I got time conversions correctly. Essentially 7:30 Eastern right now. Oh, no, not 7:30, 8:30 Eastern right now. So enough about that. We're here to talk about patterns. Now, there's lots of different things that we can talk about when it comes to patterns. We're going to focus on architectural patterns. And by the way, I forgot to mention, if you have any questions, feel free to shout them out. I have a mute button that I can just mute everyone. So you'll think I heard your question, but I have not. But in all seriousness, feel free to ask any questions that you have. I'll be taking an eye on the chat window, but it's that way or to my left. It looks like the video got turned off, so you're not seeing my video. But I will be looking and trying to keep an eye on that as we can. Okay, so software patterns. Uh, Software architecture patterns are kind of different than design patterns. When we're talking software architecture patterns, you're coming up with a solution to try and fix a problem that is always happening or more recurring, and that it's well understood. Patterns are usually solving a particular context or they're trying to overcome a challenge. You use patterns to simplify your overall application or the application design. a common phrase that you hear in the world of patterns or in software development in general is don't reinvent the wheel. And that's what software application patterns and design patterns are aimed to do. We're going to focus on the software architecture patterns, which, when you hear the two of them, software architecture patterns versus the design patterns, some people might say, how are they different or how are they not the same? And the way I like to look at it is architecture patterns tend to be a little bit larger scope, where design patterns are individual fine-grained things. So a common design pattern is logging. Logging problem has been solved multiple times. You implement iLogger in ASP.NET or get something like nlog or serial log, and it solves that problem. That's a design pattern. The architecture pattern is something like, how do I deploy this? Do I build my application in a way that is more layered? So if you look at the Visual Studio solution, some of the NuGet packages you use are more of the design pattern, where the architecture pattern is, how do my solution or how do my components talk to each other? And we're going to be talking about those conversations that our components have with each other. First one we're going to talk about is the layered pattern. This also has a couple of different names: multi-tiered, three-tiered, multi-layered. There's lots of different names, but the concept of it is that these things are layered on top of each other. So if you look at the slides from the top down, starting with our presentation layer, this is the first thing that people see. So these are typically your mobile applications, web applications, etc. Those will then talk to a different layer, which is the logic layer, things to do that control the business or what the application is trying to do. In a lot of our examples, we're going to use the order details kind of scenario. In this particular case, our logic layer would be consisting of placing an order, shipping an order, billing people, etc. Then this layer talks to or communicates with the data layer, or data tiers is outlined here. This is how we go and store information about our inventory or the sales and bills, etc. So this layer has some advantages and has some disadvantages. And by all means, none of these are prescriptive. You're going to see lots of things in everything you do. Each pattern that I'm going to show you is not an end-all be-all. There are suggestions to solve common problems. They all have their own advantages and disadvantages. In this particular case with layering, some of the advantages are you're separating the concerns. So I'm separating out how I'm going to display the data versus how I'm going to store the data. You're minimizing the dependencies because you only need to worry about communication between the different layers. Development's a little bit easier because people are kind of focused on those different layers. It's testable, it's reusable. I can pull out that logic layer, that data tier layer, and use it in multiple different applications. Some of the disadvantages of, if you make a change in the UI, that typically has to go all the way down. So if someone wants to add a new field, you're making changes to all three layers. It also means that you're typically writing some repetitive code. You're writing code here to access data, then you're doing something very similar in the logic layer, and then something similar in the data tier. And then my favorite disadvantage, which sounds kind of weird, but the conversations that happen, which layer does this belong in? I want to add X functionality, like validation is a classic example. Do I put validation at the user interface layer? Do I put it at the logic layer? Do I put it in the database layer? My personal opinion, it belongs in all three. You should never know where something is going to come from. When you're a database, you don't know who's going to send your data, so all three are responsible for it. But that's an argument or a discussion that happens a lot. So that's layered. Next one up we're going to talk about is the model view star. And it technically is not a name, but it's a common pattern. And there's 3 examples that I have on the screen for it. The model view controller, commonly known as MVC, which Microsoft introduced to their framework 5 or 6 years ago, but it's a very common pattern across software development. The model view presenter, or commonly known as MVP, and the model view model, or MVVM, which is very common in mobile development. So the MVC pattern, which is the one we'll focus on, is a pattern that's really used a lot in user interface of an application. So if we go back to that order example, or the MVC pattern is what we will see. So we have a model here. Let's just call that our order. The order gets displayed in a view. The user interacts with that model or sees the model. That user then puts a call into the controller, save, edit, delete, which ultimately updates the model and the cycle continues. These are all related to each other. Some of the advantages of this pattern is, similar to the other, it's separation of concerns. Your model, which is the data you're using, is different from the view, which is different from the controller that really owns that logic. Your presentation layer, the view, tends to be a lot more reusable. So I can use a very similar view in an HTML app that I could use in, let's say, a Blazor app or a mobile app, because I'm only working with the model. I don't have any of that business constraint in there. And one of the real popular models for this, or one of the real big advantages of this pattern, is the ability to have specialized roles. I mean, how many times I've been in software development for at least 2 weeks now, and I hear the term full stack developer a lot, which is a unicorn, and everyone has their own definition of what full stack developer is. But you hear from engineers a lot. I'm an engineer. I'm not a UI designer, which is really true. I mean, it takes a certain skill to be able to define and lay out a user interface that's effective, pleasing, and does what it needs to do. If you've been doing this for a while, like I have, there was the old term battleship gray from the days of Windows 3.1, where everything looked the same with gray text boxes and the gray buttons. It takes a lot to move on from there. So this pattern allows you to enable that a lot easily. Disadvantages is if you don't have specialized roles, but you have that full stack developer, it makes it a little bit hard because they have their fingers, quote unquote, in all the pieces of it. The next pattern, which we see a lot in many different ways, is the event-driven pattern, commonly referred to as event sourcing, pub sub, lots of different names for it. And the event-driven architecture pattern is all about events. And I know I said the word event a lot, but it's important to get the concept. So if you look here, we have an order placed event. When the order is placed, it triggers certain things to happen. It's really not triggering, although technically it could be. It really just depends on your implementation and what tools you use. The account charge needs to happen. The inventory check needs to happen. The inventory deduction needs to happen. Once that happens, the order is ready, which triggers an orders ready event, which ships the package, then updates the order. You commonly hear to this as the pub sub model. So I'm going to publish an order placed event, and these things are going to subscribe to it. I care when an order is placed because I want to make sure we bill a person for that. I care when an order is placed because I want to make sure we have that inventory available, and then I want to deduct it. If you've been doing software development for a while or familiar in the .NET stack with WinForms development or web forms development, those were the originations of event-driven development from a UI standpoint. In the Microsoft world, you double click, you drop a button onto your form, double click on it, you handle the click event. You're subscribing to that event and doing something with it. Most of what web forms is all based on those clicks. I click a button, I enter a text box, I lose focus on that text box. The event-driven architecture is very asynchronous. It allows you to say, hey, something happened, and then other things say, oh, I care about that, I care about that, I care about that, I want to do things. It also loosely couples your application. So the user interface doesn't really care about the back end. It says, hey, this person placed an order in the cart. They just hit the buy now. Everything starts to happen at that point behind the scenes by all these events that are triggered. You also see it in a lot of different types of implementations. I mean, from a software tools framework, you have Kafka, which is a popular event-driven framework. Akka, I think it's pronounced Akka. I always get that one wrong. Azure has an eventing bus. You have things like Azure messaging, message queues, Azure Service Bus, AWS, Simple Notification Service, Simple Queue Service, EventBridge. There are so many different ways because this architecture pattern enables your application to scale at a lot more, a lot easier because your components are broken up. Same time, you know, one of the disadvantages of this pattern is you have a lot of individual pieces, and sometimes the coordination between them can be challenging. The next pattern up is to talk about is CQRS, better known as the command, query, and responsibility segregation. That sounds just terrible just by itself, but most people just call it CQRS. The idea behind CQRS is you kind of separate your application into two pieces, the commands and the queries. Think of the commands as the example of, I want you to do something. And the query is, give me status of something. So if we go back to the ordering, we have this user interface here. This, let's just say it's Amazon.com. Someone clicks on add to cart, and then someone clicks on buy it now or purchase. That triggers a command to the Amazon backend saying order received. It has the details of the command that goes through a command bus. The command bus says, hey, we have this new order received. Command bus looks for things that can handle a command. So it says, okay, I know how to handle the ordering. Let me take it. Then that takes it and starts divvying up the work or handling everything, and working with the order received, the billing, the inventory deduction, drops off those things in the different repositories. So there's a repository for the order placement, one for the billing, one for the inventory deduction, and then dropping it off in an event store. And we'll come back to the event store in a minute. This also triggers other buses, other events, which say, hey, there is an order here. What do I do with it? And then you get to those event patterning that we saw before to ultimately update the data that's here. The query portion comes for, how do I get my order status or the results of those orders? That's where you come into this facade, as it's commonly called, but this query interface that says, hey, where's my order that comes through this business layer, which is very, it says thin. It doesn't necessarily need to be thin, but it's smaller than everything. It just has to do with orders, which gets the data. Like I said, I wanted to come back to the event store. The event store is a really clever concept. With the concept of event store, you're kind of putting in a black box of everything that happened. So you can replay those events. So you can reenact everything that happened from when I clicked when I raised the command to order place, all the different people, what I mean by people, applications that acted upon that event, which allows you to kind of recreate the history of it. And you've probably seen that if you looked at tracking items when you ordered something on Amazon and you see, hey, it's at this stage, now it's at this stage. Oh, it was actually shipped. So you go to UPS and see that at UPS, it left Huntsville, Alabama, and now it's in Memphis, Tennessee, because it got shipped via FedEx, and now it's on its way to Phoenix and ultimately in my garage. So those event stores allow you to see that kind of play by play. Some of the advantages of this model is it allows you to handle very complex systems like something like an Amazon or Facebook or things like that, that are very complex and can be very unperformant, so to speak, if that's even a word, because if you put everything in the code behind and doing all those steps, it's harder to scale. But by breaking it down, you can improve scalability. Security is also a lot easier to handle because you can control security at these layers as opposed to all the way up here. Some of the disadvantages, I don't know if I'd consider this one a disadvantage, but this is probably overkill for your basic, CRUD applications, create, read, update, delete. The biggest challenge that you usually run into is with data. So here you notice we have work being done here, data being updated here. Sometimes there could be some staleness between here because you're checking on orders, but all these things were fired off, not in sequence, but said, hey, someone take care of orders. Hey, someone take care of billing. Hey, someone check the inventory. Hey, someone do this. All those things are happening, and eventually they sync up and eventually get here, which means that they're available for others. However, the same flip side, synchronizing this data or inventory data across, because you can have multiple requests for one product that you only have 15 in stock. And when you showed it to the user, you had 15 in stock, but by the time they click purchase, 16 of them went out the door. So it's where you tend to come in problems with this pattern. Luckily enough, a lot of smart people help figure this out. The next pattern we're going to talk about is kind of a blending of the last two patterns. So that's the CQRS with event sourcing. Now, sorry for the blue. I totally forgot to update this diagram, and I say that every time I do this talk, and I always forget to come back and do it. But you'll notice with this, it works with the same concept. So this is pretty much split down the middle. Query side here, command side there. The only real difference is throwing in this event bus here. So we store the events. Now the event store works with the eventing bus to say, hey, who's going to handle the order subscription, who's going to handle the billing, and then you got these handlers in there says, oh, I got that, and they talk back and forth. So this is an abstraction layer away from the overall storage and query. So this is a more common pattern that you would see in the larger applications, things like an Amazon ordering or Facebook when there's status updates, that kind of stuff. An architecture pattern, which we see, another one that we see on a regular basis, but we might actually not realize we see it, is the plugin architecture pattern, aka microkernel pattern. This pattern separates everything into individual components, as I have listed here. So you have this application, let's just say Amazon.com. Amazon.com interacts with an account component, a order component, a shipping component, and an inventory component. And it just has interfaces into that. So it says, well, if I'm going to work with an inventory, I need you to support the inventory interface, which has check inventory, get inventory, deduct inventory kind of deals. So this allows you to kind of replace any of these individual elements. We do that a lot in the .NET world with dependency injection. We inject or plug in different components to do it, like logging, for example. Logging frameworks are a plugin. Most NuGet packages are a plugin in some way, shape, or form. You are outsourcing the work to something else. It has some of its own pros and cons. The biggest pro is that you can swap out these components. Let's say you're using, in our logging sample, you're using Log4Net. You realize Log4Net hasn't been updated in 4 years, and there's some newer technologies out there like serial log that catalog logging better. You can, in theory, just swap that out with the new one and get all that benefits, and your root application is none the wiser. Some of the downsides to it is there's increased coupling between these components because there has to be some agreed upon interface. Let's say you change something with the orders, you come up with a new SKU model or a new sales tax model that might need to be updated here. So you have those constraints with it. Next pattern up is the service-oriented, aka SOA, aka microservices, aka the latest trend to move everything in the world to. I said that with some sarcasm because everything seems to be microservice focused. But it's not so much that everything needs to be microservice. I think the key concept that we miss a lot is with service-oriented, it's about having dedicated services that do one thing and one thing only. So if we go back to our example with Amazon, we have our Amazon.com page, which is comprised of different pieces. So if you ever been on a slow internet connection or Amazon's just having a bad day, you'll notice that bits and pieces of the site load differently. That's because behind the scenes, they're using more of a microservices architecture, and they have different parts of the page that are outsourced to something else. So in our example where we're ordering, we have this Acme widget that is dealing with these microservices. This microservice is set for account services, so that can handle things like handle the billing, make sure that the customer is in good standing, charge their credit cards, etc. The inventory service is responsible for making sure that I have all those widgets that they want to order, or that book. When they order the book, I take it out of the inventory. I hand that inventory off to the next service, which is the shipping service that's only responsible for shipping, determining whether or not this goes UPS, FedEx, or curbside delivery, etc. And then an order service, which goes and actually handles the order, that knows that it has to talk to the account service, the inventory service, the shipping service. These are all single responsibilities, which is the key thought behind the service-oriented pattern. It's not about moving your things into an API or moving them out from one service to another. It's more about taking your application from a monolithic thought pattern and breaking it down into individual capabilities or services. This one has a lot of advantages to this pattern and one or two disadvantages, but the advantages are an increased alignment. It's a lot easier to outline your business partners or services. Like you can work closely with your accounting team and your shipping team. So it's a lot easier to see those individual elements. It also promotes better federation throughout your organization. Like you can define what's required for ordering, what's required for shipping. Also allows you to be diverse in a lot of cases. I mentioned shipping services. If you have a service that's responsible for shipping, that can say, hey, give me my options. So like here in the US, we have mostly FedEx, the post office, or UPS. We do have DHL, but no one really uses them except for international. But if some new local service comes up that's very specific to, let's say, a Seattle area, New York area, we can use those services. And the widget, Acme Widgets in this particular case, doesn't care about it or doesn't need to know about it outside of it's there for them. It also works well with a lot of agile methodologies or agile development practices, mostly because you have this separation. You can break this out into teams. You can implement features in one service without affecting all the others. Next one up. Sorry, I just took a look at the chat. Next one up, which is our final one, I believe, is serverless. Essentially, otherwise known as the cloud or the not on my PC. Essentially, someone else is running the compute power. It's commonly referred to sometimes as backend as a service, like a SQL server in the cloud, or Azure Functions, or AWS Lambdas, also referred to as functions as a service. There's lots of different names. The concept is outsourcing parts of the infrastructure and or functionality. So if you looked at the previous slide, like microservices, let's say, when I get an order, the order service says, okay, Joe, your order is done. I get a text message, an email, and a notification to my Alexa. It's sad. When I get a delivery, I have 7 Alexas in the house, so each 7 of them go off. They don't go off simultaneously. It's one beep, then another beep, then another beep, then another beep, and then my cell phone goes off because I get the alerting from the Amazon app and then a text notification. So my house goes crazy anytime we have that. Plus, the dog barks when they get it. But the point of that was outside, I'm way too connected to Amazon, is that with the serverless model, or more so the cloud, not on my PC model, you can outsource some of those things. So Amazon, I'm sure, does not have the infrastructure to handle all the notifications. And yes, they have their simple notification service, which does some of that, but they outsource that service they outsource that notification to the simple notification service, which in turn has providers like a Twilio or a SendGrid to send the emails or to send the notification. And that's where the serverless pattern really comes into play. Hopefully that LOL was at my Amazon addiction, unfortunately. I really don't want to see my 2020 spend on Amazon. That being said, we covered a lot of different patterns, and I kind of hinted to this a little bit in the beginning, but what I've given you is an overall look at 7 or 8 common patterns. And these I want you to add to your mental toolbox as different ways to solve a problem. As the old adage is, if the only tool you have is a hammer, you tend to see everything as a nail. And that is saying more so that just because you know the MVC pattern, it's not the solution for everything, or just because you know the CQRS pattern, everything does that. They each have their pros and cons, and each have a way to look at your data or a way to engineer your code. So hopefully they're giving you enough to look at and be able to go back to seeing where you have those or trigger ideas in your head. That being said, I am done with the slides, so I will open it up to any questions. Yes, Alexa is very schizo with it. She should know what room I'm in and do it. Funny story about that, and I'm going to pull up my contact information, while we're waiting. When we first started the working from home, we had I had the Alexa device in my office, and she's listening now because I see her go blue. I had it named as.
I didn't understand that.
Yes, thank you. I had it named as computer, and you'd be surprised on how many calls we used the word computer. So it was always going off. Any comments on the clean architecture similar to plugin? I feel like I should be saying Bueller, or showing that that GIF from Ferris Bueller's Day Off. In any case, if there are no questions, or if you come up with a question afterwards, feel free to reach out to me on any one of these things. Active on Twitter. My email address is my Twitter handle at hotmail.com, or connect to me on LinkedIn. You can also contact me on my blog, where you'll see blog posts around this and many other topics. If you like what you've seen, come watch me on stream. I'll actually probably be streaming in a half hour or so, migrating an application from .NET Framework 4.6 to .NET 5, which I've been working on for a couple of weeks now.
All right. Anyone have any other questions? Oh, Adams had a question. Any comments on the clean architecture? I don't know what that is.
Are you referring to the book series on clean architecture, Adam?
AKA Onion. Okay, that didn't help me.
Yeah, there's a couple of different books around clean architecture. I mean, there's lots of different viewpoints on architecture. Like I tried to say at the beginning, is these are different patterns or different tools to use to solve a sorted problem.
Yeah, I hope the Onion reference isn't an architecture that makes you cry.
No. There's a onion architecture is a common way to refer to as the layered architecture.
Okay.
Shrek
Right.
said in I can't even think of the show. Onion or ogres have layers. Architectures have layers, and they compare them to onion. So clean architecture, it's actually a book series. I think there's 3 books in it that talk about many different patterns, very similar to this. Steve Smith, aka Argus, does a great talk about architecture. He has a podcast and a stream around it. It has a couple of Pluralsight videos on it. It moves the business entities logics to the center, so they're not dependent on data as much as yes. So that's a very typical thing based on your last statement, Adam. It moves business entities and logic to the center. Yes, that's very common in the plugin architecture pattern where you see a lot of that. You can also do some of that in the MVVM or MV star pattern, where the data is not really part of it. It's the model that you really care about, and the data is an after effect. In a lot of cases, that's more of a progressive way. I started showing the patterns in a beginner level all the way up to more advanced, and it probably shouldn't be beginner, more advanced, more simplistic, and more complex, but they all solve different problems. Hopefully that answered your question. We should probably stop sharing, because now I'm sharing the Teams meeting, which is probably awkward.
Any other questions for Joe?
You're welcome, Adam. Cool.
Okay. Well, Joe, thank you very, very much for taking the time to do this. This was very informative. And now I'm going to go look up
Thank you very much, Joe.
architecture pattern references.
No worries. There's lots of them out there. And like I told you beforehand, I'll reach out to Woody. If you need help with any other topics, you can go to my site in what you put in the meetup, and there's lots of other talks I can do with.
Yeah.
Okay.
When you talk to Woody, don't mention my name, or otherwise he'll tell you to get lost. No, Woody's a good guy. Woody's a good guy.
And for those of you who came in late, this recording will be up on Joe's YouTube channel. We have to finish the recording and do some gymnastics to get it over to him. We'll make it happen, and we'll post an announcement on the meetup page when all that is in place. So again, Joe, thank you very much for taking the time.
It was a pleasure. Hopefully in the near future we get to see each other in person.
I look forward to it. All right, everyone.
All right.
See you next month. Joe, take care.
Bye.
All right. Later, everybody.
Thank you, Joe.